welcome back to my YouTube channel. In today's video, we're going to be looking at proportional lengths, especially in triangles. Let's jump right into it. The first thing you need to understand when we're talking about proportional lengths in triangles is this theorem. The official name of this theorem is the Triangle Proportionality Theorem. And it says that if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Let me break this down for you. This theorem states that in this triangle, since these two lines right here and right here are parallel to each other, then we can say that AD over DB is equal to CE over EB. Knowing this proportionality theorem will help you solve for sides of triangles a lot quicker. Let's go ahead and try some problems now. Alright, so for these problems, we need to solve for x. Let's go ahead and use the triangle proportionality theorem, which we just learned, to try to solve for x here. So we can go ahead and say that 4 over 5 is going to equal 6 over x. Notice how since both 4 and 6 are on the top, both 4 and 6 are on the top of our fractions here. Same thing goes for 5 and x. Now all we need to do is do cross multiplication, or as we talked about in the last video, something called the means extremes property. Your geometry book may label this property in a different way as well. So 4x is going to equal 30. If we take 30 divided by 4, our final answer is that x equals 7.5. So over here, we can replace x with 7.5. All right, let's try another problem. All right, so let's go ahead and do the exact same thing that we did previously. So our two tops numbers are both 10 and 15. Now our bottom number over here is going to be x minus 10, because we know that the length of the entire side is x, and one part of that side is 10. So x minus 10 is going to tell us what our unknown side would be. And the other bottom one over here is 24. Now all we need to do is some cross multiplication. 240 plus 150 is going to equal 390. So you know that 390 equals 15x. 390 divided by 15 equals 26, so our x equals 26. So now that we know that the entire length of this side equals 26, we can also do some simple math to deduce that the unknown side over here would be 16. All right, I'm going to teach you one more theorem that has to do with proportionality. This theorem is called the triangle Angle-Bisector theorem, and it says that if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. Let me make this a little more clear. All right, so let's say that we have this triangle, and AD is our ray that bisects angle A into angle 1 and angle 2. So this triangle Angle-Bisector theorem states that if this ray bisects this angle, which means that angle 1 and angle 2 are going to be congruent, then we could say that BD over DC is going to be equivalent to AB over AC. To simplify this a little bit further for you, the two sides here and here are going to be equivalent to the sides over here and over here. Let's go ahead and try a few problems using this theorem. All right, so you can see in this triangle that it's a little different because our angles are congruent to each other instead of having parallel segments. So let's go ahead and solve for x. So I'm going to go ahead and do the triangle that is on the left first. So it's going to be 42 minus x over here and that is going to be equal to our 36, and then the numbers on the right, which would be over x and over 27. So remember that these two up here are always going to be on one fraction, and then these two over here are going to be on the separate fraction. However, we want to make sure that those numbers are equaling the correct thing. So you can look at the two triangles that are being made to figure out that. All right, let's go ahead and do our cross multiplication or our means extremes property, however you'd like to call it. So it would be 36x equals 1,134 minus 27x. 27 plus 36 equals 63x, and 1,134 divided by 63 equals 18. So our x is going to equal 18. Let's go ahead and try one more problem like this just to reinforce it in your mind. All right, this is our next triangle. Remember that we're trying to solve for x. However, instead of knowing the length of this segment right here, we are told that the entire thing is 40. But we can do some simple math to figure out this length right here, which would be 40 minus 25. 40 minus 25 equals 15. Now that we have all of our information known, we can go ahead and set up our proportion. So remember, it's going to be 15 over 25, which is our two top ones over here. And then we need to get the right number on top. So since 18 is in the same triangle as 15, which is this little triangle right over here, we're going to have 18 on the top and x on the bottom. All that is left is to do some simple cross multiplication, which would be 15x equals 25 times 18, which is 450. 450 divided by 15 equals 30. So our x is going to equal 30. Now I decided that I'm going to give you guys some extra word problem help with these triangle proportions, putting them into practice as we just use them. These problems are known as shadow problems, as a lot of the word problems have the use of shadows in them. I'm going to go ahead and read the first problem to you. So the first problem says, on level ground, the base of a tree is 20 feet from the bottom of a 48-foot flagpole. The tree is shorter than the pole. At a certain time, their shadows end at the same point, 60 feet from the base of the flagpole. How tall is the tree? All right, let's go ahead and start off by drawing our problem. So we are told that the flagpole is 48 feet tall. Next, we know that the base of a tree, which we can draw right here, is 20 feet away from the flagpole. At the same time, their shadows meet at an end, which is 60 feet away from the flagpole. So we could put 40 over here because we know that this total distance is 60 feet. Our goal is to find the measurement of x. Now, something interesting about this problem is that we can't use the new theorem that we learned today, which is the triangle proportionality theorem, because these two lines here, the tree and the flagpole, are parallel to each other. And we can't use the shortcut theorem for parallel lines. So we're going to have to do it the longer, old-fashioned way, which means that we're going to have 40 over the entire triangle. So we're going to look at the small triangle right here. And then we're going to look at our bigger triangle over here. So we're going to have 40, which is our short triangle's long leg length, and then 60, which is our big triangle's long leg length. And that is going to equal the short leg length of our short triangle, which is x, and the short leg length of our big triangle, which is 48. Now that we have our equation set up, all we need to do is solve for x. So 60x is going to equal 1,920. We're just going to do some division. 1,920 divided by 60 equals 32. So we know that the height of the tree is 32 feet. All right, just for bonus, we're going to do one more shadow problem. This problem reads this. Sarah is 5 foot tall and casts a shadow of 10 feet. A tree is 18 feet tall. How long is the shadow that the tree casts? Assuming that the sun is in the same position. So for this problem, we aren't told that the shadows meet in the same point. So we can't draw these two different triangles together like we did in the last problem. By the way, that type of triangle is called a nested triangle. So we cannot draw a nested triangle for this. So let's start off by saying that Sarah is 5 feet tall. And her shadow is 12 feet long. Let's go ahead and draw the triangle for this. So if Sarah is 5 feet tall, she's going to cast a shadow that's 12 feet long. Now our tree is 18 feet tall. But we don't know how long the shadow is that the tree casts. So we're going to go ahead and draw another triangle. The tree is 18 feet tall, and we want to find out how long the triangle is. So we can go ahead and just go right across. So 5 over 18 is going to equal 12 over x. Now we can go ahead and just solve for x. So 5x is going to equal 18 times 12. And 18 times 12 equals 216. So we know that 5x equals 216. 216 divided by 5 equals 43.2. So we know that the tree casts a shadow of 43.2 feet. Thank you guys so much for watching this video about proportional lengths. I hope that you really enjoyed it. If you found this video helpful, please give it a like and subscribe to my channel down below if you haven't already. Thanks again for watching, and I'll see you in the next video. Bye!